Viewers, you are watching Mathematics channel number Collage. In this video, we will understand characteristic equation, eigenvalues, and eigenvectors. We are given matrix A from which we have to write its characteristic equation, and after that we have to find its eigenvalues and eigenvectors. First of all, let us understand what is characteristic equation of a given matrix. If A is a given matrix, then determinant of A minus lambda I equals 0 is known as characteristic equation of matrix A. So, if A is matrix 1, 2, 4, 3 as given in the question, then determinant of A minus lambda I equals 0 gives us its characteristic equation. So, A minus lambda I will be matrix A minus lambda times unit matrix 1, 0, 0, 1. That will be matrix 1, 2, 4, 3 plus matrix minus lambda 0, 0 minus lambda. A minus lambda I will be matrix 1 minus lambda 2, 4, 3 minus lambda, and the characteristic equation will be determinant A minus lambda I equals 0, that is determinant 1 minus lambda 2, 4, 3 minus lambda equals 0, 1 minus lambda into 3 minus lambda minus 8 equals 0, 3 minus lambda minus 3 lambda plus lambda square minus 8 equals 0, lambda square minus 4 lambda minus 5 equals 0, lambda minus 5 into lambda plus 1 equals 0, lambda equals 5 and lambda equals minus 1. Here lambda square minus 4 lambda minus 5 equals 0 is the characteristic equation of matrix A, and its roots lambda equals 5 and lambda equals minus 1 are called its eigenvalues. So here minus 1 and 5 are the eigenvalues of matrix A. From these eigenvalues, now we will move forward to find corresponding eigenvectors. But before that, let us understand two important properties of eigenvalues. Number one, sum of eigenvalues, in this case 5 minus 1, is same as sum of diagonal elements of the matrix, which is in this case 1 plus 3, 4. Number 2, product of eigenvalues minus 1 into 5 equals determinant of matrix A, which in this case is 1 into 3, 3 minus 4 into 2, 8, which is minus 5. Next, we will find out the eigenvectors corresponding to the eigenvalues minus 1 and 5. But before that, let us understand the concept of eigenvector. Suppose lambda 1 is an eigenvalue obtained from characteristic equation determinant A minus lambda I equals 0. Further, suppose we find a non-zero column matrix X such that matrix A minus lambda I into matrix X equals a zero matrix. Obviously, this system of equations has a non-trivial solution because there is zero vector on the right hand side, as we have discussed in the previous videos. Here, this vector x is called the eigenvector corresponding to the eigenvalue lambda 1. In the present case, determinant A is 1, 2, 4, 3 and eigenvalues lambda 1 is minus 1 and lambda 2, 5. Now we will find out eigenvector for each eigenvalue. So first, eigenvector for lambda 1 equals minus 1. We have A minus 1 into I into x equals 0, where x is the eigenvector corresponding to eigenvalue minus 1. 1, 2, 4, 3 matrix plus 1 into identity matrix will be 1, 0, 0, 1. Column matrix x1, x2 equals 0 matrix 0, 0. Now 1 plus 1, 2, 2 4, 4 into x1, x2 equals 0 matrix. For converting coefficient matrix into row echelon form, we will perform R2 minus 2R1 giving us 2, 2, 0, 0. Rest remaining the same. We will get 2x1 plus 2x2 equals 0. x1 plus x2 equals 0. We will put x2 equals t. So this equation becomes x1 plus t equals 0, giving us x1 equals minus t. Now by putting t equals 1, we get x2 equals 1 and x1 minus 1. So the eigenvector x will be minus 1, 1. Let us note that any non-zero multiple k of x gives us the eigenvector corresponding to eigenvalue lambda 1 equals minus 1. Next we will find eigenvector corresponding to eigenvalue lambda 2 equals 5. So number 2 eigenvalue lambda 2 equals 5. We write matrix A minus lambda 2I into X equals 0 matrix. Matrix A minus 5I into X equals 0. Matrix 1, 2, 4, 3 minus 5 unit matrix 1, 0, 0, 1 into matrix x1 x2 equals 0 matrix. This will be matrix 1 minus 5 minus 4 2 4 3 minus 5 minus 2, rest remaining the same. To make these two elements 0, we will perform R2 plus R1 second row 0 minus 4 2 first row. Rest is the same. We get minus 4x1 plus 2x2 equals 0. Putting x1 equals t, x2 will be 2t, and if t is 1, x1 is 1 and x2 2, and hence eigenvector x will be column matrix 1 2, and its any non-zero multiple k will be the eigenvector corresponding to eigenvalue lambda 2 equals 5. Viewers, if you like this video, please like, share and subscribe this channel, Number Collage. See you in the next video. Until then, keep watching Number Collage. Thank you.